There is an old story. You've heard a version of this, I'm sure. Transmitter goes off the air. The owner calls in an engineer. Engineer comes to the transmitter shack, takes a look at the transmitter, walks around the transmitter, takes a moment, moves over to the side, kicks the side of the transmitter, and it's back on the air. Well, great. Soon the engineer sends an invoice to the owner of the station for $500 or $750, or depending on when you've heard this and inflation. And the owner says, wait a minute, it only took you 20 seconds to get me back on the air. And the engineer says, well, that was $50, or rather, that was $500 for uh, knowing where to hit and $50 for hitting it. Did I just blow that joke? But it really is true. Troubleshooting is a matter of education in many ways, which we get over a period of time, either by having things happen to ourselves or by learning it from others. And I'm happy to have Gary Minker with us today, among others. I'm sure every one of you have had some issue that you've dealt with, that maybe it was a cold solder joint in a exciter, or something in the transmitter that overheated, or when the AC goes out and the transmitter kind of gets angry when you're at 120 degrees in the building. And so we can talk about some of these things. But I especially wanted to have Gary talk to us just a little bit here, because Gary, when I got to know him, one of the things he preached, and I think it's a very good thing, especially for FM, is line sweeping should be done on a fairly regular basis, just like tower guy tensioning and watching your guy anchors, watching your paint. All these things go into really a proper maintenance protocol. And if you've been reading on the BDR for the last couple of weeks, a couple of interesting little articles that Gary wrote. The one entitled "My Transmission Line Can Hear," and then yesterday we put up "My Tower Can Hear," and it's a story finding a problem and solving that problem. And so, Gary, would you like to introduce yourself here and let us see you and get started? You may have to unmute yourself. Use an alternate A or a space bar.
If only it would cooperate. It's a lot of names I see on print and in other publications, and people who have been around the block at least, I don't know, who wins, 10 times? A couple of you I know have only been around the block once or twice. RF is really fun and has another 300 or 400 acronyms. And it's one of those things that whether it's AM, FM, and whatever things you try to assign for the verbiage to the resistor color code, this is something that all of us have had some fun with. Some of us have made a decent living at, and some of you work for large groups, some of you work for small groups, and some of you, like me, are members of the gainfully self-unemployed, if not on your way to retirement. And I keep hoping that the industry will not retire me before I'm ready to give up, because I am not going down without a fight. This is my 43rd or 44th or 45th year of fixing people's broken stuff just in the RF industry. Is going back toward the not quite the beginning when dirt was new. I worked in a hi-fi shop as a young apprentice at 12 years old. The guys thought it'd be funny to teach the kid how to work on color TVs and see if he could get himself killed. But it never happened because I learned how to keep one hand in my pocket and still have both hands. So what you wind up with after you've been around the block a time or two and you keep your eyes open and you don't forget that everything that you do is something that can teach you something, you wind up by osmosis, if not by accident, learning from other people's mistakes. And even though it's really handy if you learn the right way the first time, some of us don't have that pleasure. I used to really enjoy going to the factory and sitting with the people at the factory who are supposed to be the grand viziers of what's going on. And I would ask them, so you take your left hand and you go like this, and something happens. Well, what happens if you do that with your right hand? And at least not, it seems to work. So that's what I do. And all the air runs out of my head, and I go, well, okay, at least I asked. But every now and then you ask that kind of a question, and the guy comes up with, well, if you use the wrong hand and you turn it the right way, bells go off and things go wrong, and the trace doesn't exactly sit right, and the frequency hops all over the place, and whatever it is you're working on turns green and purple, and it never quite works out. But if you use the other hand, it's a 3-second deal and you're on to the next project. And the light goes on. And you go, wow, that mind-blowing. How just a simple thing, a simple act, a simple question, a careful observation of watching somebody else do the right or the wrong thing to achieve the same goal, but they get there so much quicker and they get there so much more accurately. And that's the part of the deal in troubleshooting that everybody tries to strive for. Because even if you're paid by the hour or by the job or however it is, if you get the job done early, you get to go to lunch and send them the bill for the same amount of money. That's if you're truly and totally a mercenary, and I am one. But after 40-something years of treating people right, I'm still working for myself. Either I've been fooling a lot of people or I've made a number of friends over the years.
Well, that makes a lot of sense. I mean, if you're going to go out door to door, you can't just, again, like that owner wants to know why it cost him 500 or $1,000 to kick the transmitter. Your time is valuable. I have one Native American station. It's 100 miles door to door for me, and I know there's many others out there that drive distances like that, and so you can't expect them. Uh, you can't let them expect you to charge just for your actual troubleshooting time.
Well, I have a theory about a lot of the troubleshooting. First and foremost, it makes me happy that people are really happy to see me get to a site and do the things that I do. What I try not to let it get to me about is at the end of the job and it's all over, they're not just really happy, they're really, really, really happy to see my tail lights go down the driveway. And of course, you could develop a complex over that, but you have to realize that, hey, you made them happy, it was good. And whether I was there for an hour or 10 hours, I danced and I sang and I told great jokes and I tried to teach everybody there something, even if it was just to sit there, smile, and keep your hand in your pocket.
That is
Bottom line
that's got
is,
to be that's got to be lesson number one, doesn't it?
well, over the years, I'm pleased to say that I have only been foisted upon to work with certain individuals who I had to go to them and their manager and say, I want you to sit in that chair. I don't want you to get up from that chair. If you have to get up from that chair, I want you to wave a hand in the air. You will tell me why you want to get up from that chair, and I'll decide if you should go do that or not, and then you will come back to that chair because you scare the crap out of me, and I'm not going to want to worry about me and you. And of course, that upsets a lot of people, but rule number one, Gary goes home safe at the end of the day. Everybody else is a good idea, but optional. So you have to look out for the safety of those around you. And if it involves stepping on some toes, so be it. But after having miscellaneous run-ins with people over the last 40 plus years, it just comes down to the simple fact, you come to a site to fix something, you are in charge.
You have
You
to
are
be.
large and in charge.
You have to be.
And that's the bottom line. I've told managers to chill out and get a beer. I've told them to leave my job site. I've told them not to keep calling the engineer on the property because you've turned him into a nervous wreck. And I need his 100% attention and cooperation. So if you keep telling me you want to be the first one to know, I'm sorry, Buckwheat, but you're going to be the ninth one to know because I got 8 people here who are going to know before you. And then we'll think about maybe calling you just to keep you in the loop. But you have to understand there's 2 important things. Number 1, you are large and in charge. Number 2, everything has to happen on your time frame. Everything else just comes after that because everyone is looking to you for the answers. And if they push you or distract you or damage you in any way, then bad things happen. And then somebody comes up and says, well, you've been at this a really long time. What's the deal? And you can calmly look at them and say, well, we've made this progress and this progress and this progress. And if this displeases you, this was broke when I got here, my friend, and it can be broke when I leave. And that's not a tack that you'd like to take with a client, but some people just beg you for that kind of stern tone. And then it usually works out well in the end. But the bottom line is you're large and in charge, and you're occupied with everybody's safety.
And the way that often gets violated is when you get to the building and the phone is already ringing. How long will it be before we get back on?
No, not the first time I'd have unplugged somebody's phone.
Yeah.
I've snatched a few cell phones from engineers and asked, who is this on the other end? And I usually get some screaming manager. And I have no problem telling them to chill out and get a beer. And by the way, don't call back.
Yeah. Probably number 2, and it's different today, isn't it? Because of the way equipment is run on IP. But it used to be that the number 2 thing you do after you put your hand in your pocket is put the remote control in the local.
Oh no, that's the first thing I do. When you walk in the building, I have enough experience with enough different situations that I can walk up to pretty much any transmitter, give it the hairy eyeball and go, that needs to change. And if something can't be put into local and or high voltage sections can't be disabled, then we have to do the whole lockout, tag out thing and make things die. Because that way, somebody who is not under my control and not on the site has the ability to kill one of us. And I'm not real fond of that. It hurts. And I'm not real happy with the concept of hurting the whole time I'm dying. That's been tried a couple of times, and I'm pleased to say they missed. But you are in charge, and you are in charge of everybody's safety.
Yeah. If you've got your hands inside a transmitter and it suddenly turns on, I don't know of many more things that are as frightening.
Well, trust me, you can't move fast enough. I did marine work for a while, and I was laying on top of a very large MAN diesel on my back, working on something on the overhead. And I had a sign in the wheelhouse says, technician in engine room, do not start. And I'm laying up there and I hear footsteps above. And the next thing I hear is everything in the engine room coming to life and clicking. And I knew that my way off the top of that block was past 3 live belts. So I figured I better get a move on and slither out of there like an angry snake. And I just cleared the belts when the guy rolled the engine over. Just nothing breeds terror like the thought of getting chopped up in the meat chopper.
Yeah, absolutely. Gary, is your microphone covered by something?
No, it for some reason it's only about a foot away from me, and it just seems to have gotten muddy over the last month or so.
Ah,
I'll have to look into a headset or something. I'll speak up. I can't move it any closer though.
okay. Well,
But
a couple
I,
folks have mentioned it. So,
for for people who work on difficult things, for people who work on dangerous things, when you go anywhere, I want you to have two thoughts in mind first. And a lot of people will think this is funny, but it's deadly serious. I want you to think for a second how many ways there are to stick your finger in the fan. The answer, of course, is two: the not good way and the worse way. The not good way, it's just going to bite you and tell you not to do that. The worst way, and you're going to lose a finger. So which is it? Which is it going to be? Can you watch other people learn and learn from their mistakes? And hopefully everybody goes home at the end of the day safe. Or is something worse going to happen? Safety, safety, safety. And it applies to every form of troubleshooting, whether it's generators, electrical, RF, transmission line, transmitters, tubes, solid state. Pick a topic. I love a good debate and a conversation. There's not a whole lot of topics people can pick that I can't hold my own in. And I love to have these conversations, especially with troubleshooting. I've got gigabytes of files of sweeping and repairs of just about every kind. I've got thermal imaging, generator stories. They're all a laugh a minute.
well, where would you like to start? Let's do a little troubleshooting here.
Anybody have a particular favorite topic? Somebody spill.
Well, let's start with the thought of an FM station where the reflected power is slowly rising or has
Uh,
jumped.
whenever if you're intimately familiar with your transmitter, whether it's AM, TV, FM, and you're Johnny on the spot with the tranny, you know what it does all the time. You take reasonably frequent readings, you write them down, and you walk in and you notice a trend that's not so wonderful. It would be good if you have implemented one of the things that I like to promote. If you have an external metering source other than the transmitter, what a lot of people do is they have a meter on the transmitter for forward and reflected, and you have an external meter of some kind, whether it's Bird or coaxial dynamics or any of Maycom, whoever it is. With the removable slug type meters, the slug manufacturer meters only claim a 20 dB sensitivity with a 5% accuracy. So, or 20 dB, I'm sorry. 20 dB down from your primary carrier power is still pretty rude. Now, if you have a 50 kilowatt slug in there, a 5,000 watt slug isn't going to tell you a whole lot. A 500 watt slug may try and tell you something's going on, but it's just really not your walk in the park. What I promote is 50 watt slugs. And I've caught a lot of grief from the slug manufacturers for recommending this, but you put in your primary power slug, which is a single 50, for example, and you get a pair of 50s for the reflected. And it really doesn't matter to me if they're the right size, if they're the right B number, if they're meant for that diameter of sample section. None of that matters, because as the manufacturers are always quick to remind me, they're not calibratable, they're not accurate. Oh, we're only good at 20 dB down. It doesn't matter. That's not the point. The point is you buy two of these slugs. You put one slug in when everything is hot, straight, and normal, and you write down what the reflected number is. You take it out and you put the other slug in, and you write down that number when it's all hot, straight, and normal. And they may not be the same, they may not be close, they might be worlds apart in their little 50 watt scale. But the point is, you write it on its little box, and you go, this slug reads 28 watts. This slug reads 37 watts. And you come in one day and your 28-watt slug is sitting at 42 watts. And you go, haha, Gary said, change the slug. So you put in the second slug, and your second slug does not read higher. Well, you know you popped a slug. Phew. All right, we're safe. We skated. Good deal. Buy another pair of slugs, put them in, or one replacement slug, and put it in, write its little number down, compare the other one, write its little number down, and then go away. And 3 months later, you come in and slug number one reads 42 watts. And you look at that and you go, are we playing this game again? So you take it out and you put in the second slug, and it reads 12 watts higher than it used to. That's when you get your phone out, you call your favorite tower crew and your favorite line sweeper, and you organize a raiding party, call the suit in the front office and tell them it's going to be dark for a while. Because you know at that point you have double corroboration, if not triple, with the meter on the transmitter to know that you've got a problem in the line. So that's your first line of defense. It's simple, it's quick, it's cheap. It doesn't really cost anything, and you didn't have to go off the air to do it. And then once you've pretty much corroborated the fact that you've got a problem, you call all the troops in, then the numbers are going to flow, the dollars are going to add up, and you got to figure out what the real truth is. And then you have to look and see, hopefully it's your line sweeper is someone you know, love, and trust. You might not want them to date your sister, but you know, love, and trust them. And you get into the line with the appropriate adapter, and you can tell whether it's the line or the antenna or what have you. Mr. Walt, is that a hi or you have a question?
All right. Well, first of all, you've got a very excellent tip here, is not to ever rely on one single diagnostic tool, and to have two slugs. That's a great idea. Roland Lindhag has put up here in the chat, an FM station with a rising VISWAR may mean some arcing may be going on in the coaxial cable. Isn't it better to isolate first whether the issue is on the transmitter versus outside the transmitter?
Okay. You've got some mixed metaphors in there. If you have active arcing and a properly operating transmitter, the transmitter is going to see that and it's going to go flat on its face. Transmitter reflectometers today are so fast that any perceivable measure of arcing is going to trip the transmitter off. And it doesn't matter where in the line it is. The fact of the matter is an arc will shut the transmitter down. And then you get into the steps of progressive troubleshooting. And he did touch on the right point. Nobody wants to think their transmitter is broken. And that's a very different kind of troubleshooting. So we're gonna say there's nothing wrong with the transmitter. You got to start somewhere. We're going to take this from the standpoint of, now we've got two scenarios. Whether the reflectometer is rising slowly from day to day to day to day through a week and through 2 weeks or 3 weeks, and it's creeping its way up, or if while doing that, there is an active arc, you may not have crossed 1.2, 1.25, 1.3, whatever your manufacturer has set the pain point at for shutdown in your transmitter. The slow creep may not trip that yet, but chances are good that any kind of an active arc will. It happens so fast in such fractions of a millisecond, where if you cut a carbon track across an insulator, the transmitter will see that and it will shut it down. And whether it goes for a three strike startup, depends how you set the box, but that's a pretty good indicator. If you notice that your VISWAR is creeping and you go out there and fire it up again, but it's still sitting around 1.2-ish, but the transmitter shut itself off, you can fairly well assume that you've got something arcing up there. Then the question is, you send a crew up, you put a cap and a load in the end of it, you do an open and a load, you characterize the line, you check the line for clean time domain, for clean return loss, you check its Smith chart, which tells you a lot right there in the one picture. And if your return loss, your Smith chart, and your VSWR graphs all look pretty, and you don't see anything weird looking on the time domain, chances are pretty fair bet you got an antenna problem. So then you hook back up to the antenna and things go haywire. You're pretty fair bet you got an antenna problem. And all of that kind of troubleshooting with somebody that knows how to look at the screens, that's a 4-minute flat deal. It takes you longer to hook into the line, get cowled up and get ready to take a drink of your soda than it does to diagnose whether or not you got a line or an antenna problem.
Well, you just took my question away. How long does it take to sweep a line and find the problem? How accurate would you be if you say you've got, oh, let's just say a 500-foot line of coax? How accurate can you be with your TDR?
3 decimals to the right of 0. Well, let me rephrase that. With the Anritsu, it was 4 decimals to the right of 0 because I used to run a Lightning, and I run a Copper Mountain now and have for a couple of years. And if you have absolutely lost your mind, you can set that for 7 digits to the right of 0, but that's kind of pointless. 3 or 4 decimals to the right of 0 gets you down into the millimeter range, and your accuracy as to location of linear distance from the test point to the failure is going to be more screwed up by the error in velocity factor that you assign to the test than anything else. Because I don't care what they publish in the book. I don't care what kind of line it is. I don't care how new or old it is. If it was made on a Tuesday and then a Thursday, and then its other pieces were made on a Saturday, all 3 of them are going to have a different velocity factor. I don't care what the book says. You're just assigning a number like 0.93, 0.98, 0.99. And the only ones that are reasonably constant are open copper airlines. But any kind of other flexible product, your velocity factor is a total crapshoot. And elliptical, by the way, is for microwave is also a total crapshoot.
So how do you find where the problem is?
Oh, I'm usually never more than 10 feet off on a 1,000-foot run. If I say, okay, count the flanges, go up to 962 feet, and you will find a flange. That's kind of the way my old chemistry teacher used to do that. He wrote his own book. He was on book 5. Never opened the book. It sat on the front desk, and he would bang on it. On page 432, you will find, and the guy was never wrong. So I tell him, go up 972 feet, you'll find a flange. Loosen the bolts on it. Let me watch you. If you're right on target, I'll know. If you're 1 or 2 flanges high or low, I'll know. I'll be able to fix that. Just loosen them, don't break them, don't open them. And as I see them playing with the last bolt, I go, okay, go up 1 flange, go down 1 flange. That's where the problem is. I'm pat myself on the back. I'm sorry, but I just never miss.
That was really the theme of your article there on My Tower Can Hear, wasn't it? That you were watching as they were hitting the tower with the hammer, and you could see where the problem was.
This is a fun pair of articles. And if you've ever done line sweeping, or you've ever watched somebody do line sweeping, the pair of articles, one of them is My Transmission Line Can Hear, and the most recent one is My Tower Can Hear. And you think, well, that's pretty stupid, and I must have been tripping when I wrote it. But the fact of the matter is, the first one with My Line Can Hear is, I have a very old customer. He's a old farmer, wears overalls, owns an FM station, called me up one day and said, I'm here to tell you I've seen it myself. I was out to the transmitter, it's been giving me trouble, and I saw the lightning, and 15 seconds later I heard the thunder and the transmitter shut off. My line can hear, my transmitter can hear, something can hear. It heard the thunder and down it went. Oh, no, goody. I know what that is. I say, you got a line problem. He goes, nah, it can't be. It's got to have ears it can hear. So I'll tell you what, I will pay for the crew. I will pay for me. I will pay for everything. We will all come up. We will shut you down. We'll get into the line and we will make tests. And if I'm wrong, I pay for the whole day and night. If I'm right, you owe us way more than dinner. He said, you're on. So we go, meet, show up, crew gets together, everybody suits up. I hand the lead climber a 2-pound rubber hammer. I tell him to go up to the top. I want you to go to the first flange at the beginning of the antenna. And I set the analyzer to run lickety split, and I put it in peak hold. I said, I want you to fram the first joint 3 times and then stop. So he goes up, frams the joint 3 times, and nothing happens. And I'm looking at the whole line, all 14 or 16 joints. I said, okay, good one. And I've got a little check sheet, and I start checking them off. He goes down to the next one. Bang, 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 nothing. Next one, bang, bang, ding. The snake jumps up out of the grass in time domain. Okay, that's 1. He says, 1 what? I said, 1 bad joint. Next. All in all, we had a pile of bad joints. All the bullets were getting flaky, and his line needed a rehab, a cleaning, and all new bullets. So, okay, great job, good fun. Everybody had a big laugh. But this most recent one, this one was a stinker. And Barry just is going to publish the article here. And of course, all of these are on my website. There's 30-something articles on RadioWorks, rfconsulting.com. This one was a good one. The tower is owned by a First Nations tribe. And there's a couple of tenants on it. And they've been having interference complaints with the trunking system for well over a year. And the only thing that seems to make it go away is to run the FM at half power or less. So it's in a really remote location and the weather is really crummy there. So trying to get the crew to go out and do different things, whether it's electronic or mechanical, is a huge delay game. So a lot of the electronical type people went out there for a meeting, and I've been joining them by face chat on my cell phone. So they set me up on somebody's phone on a stand, and I sit there and I watch everybody and we can talk. And they brought a assortment of spectrum analyzers out. And I said, I want you to watch the receive system on the trunking system with a spectrum analyzer set up a special way, run real fast. And because we hadn't been able to get a tower crew out there to go do a physical bolt inspection, I said, who's got a big hammer? And they thought it was a joke. And one of the guys laughs and he says, yeah, I got a hammer. I got a 5-pound maul. What of it? I said, I want you to take it out to the base of the tower and I want you to fram that thing as hard as you can 10 times. And they thought that I had completely lost my marbles. So then it turned into a play-by-play, blow-by-blow deal. He's picking up the hammer. He's walking out the door. He's approaching the base of the tower. Wham, wham. And I'm watching the spectrum analyzer just kind of diddling along with active traffic, nothing big. It's got a narrow bandwidth because it's got a comb line filter on it for the receiver. And he hauls off. After the 10th hit, he goes, well, what happened? I go, well, I don't see anything yet. I said, give it all you got. Just go for it. Go for it. And he hit that thing so hard, I could hear it all the way inside the building. And the spectrum analyzer just came alive. It was like an instant grow chia pet. This thing grew fuzz and hair all over the place. I said, okay, that was pretty cool. Let's see if we can do it a second time. So they cleared the peak hold. And the guy said, that was pretty crazy. I'm going to hit it really hard. Wham! And I know he was a good 30, 40 feet from me, and I could still hear the ding of the tower. He hit that thing in the, hey, here's your problem. You got a mechanical problem on the tower. You've got bolt arcing in the aperture of the forebay. And sure enough, they got a crew out there and they found all kinds of arc marks around the 3/4 bolts holding the leg pads. So they went up and down the entire tower, loosened every nut on the tower, sprayed galved it, put the nut back on, torqued it, and then spray galved it again. Talk about complete service. And so far, it hasn't reared its ugly head again. So sometimes unconventional methods of troubleshooting may seem like a joke, but they're actually the best thing to do. You got to think outside the box.
That's probably true with a lot of towers that over a period of time, the hardware begins to have a little problem.
And
And
transmitters do the same thing. When I took over an AM station, we had a MW5, and that was the best sounding transmitter on the green earth. I was in a big audio competition with one of the other local stations, and I used to pre-process my audio ahead of the Optima, and man, was that sweet. But the transmitter developed a nasty little problem where if the power would go out, the power would come back on, the blower would come on, and the filaments wouldn't kick in. And I was new to the station, and we had so many other problems going on that just out of frustration, trying to get the thing to go, I did the old Fonzarelli on the thing right in between the RF tube and the modulator tube shelf. Now I whacked that thing pretty hard, bruised the back of my hand, and the relay for the filament kicked in. And I thought, okay, this is too strange, but I need it back on the air. So I left it running, warmed the filaments up, and put the transmitter back on the air. So later that day, I thought, all right, I'm going to try this. So I turned it off. Go to turn it back on, turn on the blower. Blower comes up to what sounded like good speed, what sounded like good pressure, no filaments. So I pop the back open and I see the air vane in the plenum popping around, wiggling around. And I'm going, I got flow. So I just reached in there and I went flink to the air vane switch and the filaments turned on. I'm thinking, what have I got, a bad switch or what? So I turn it off. The pressure goes down and I'm in there playing with the micro switch. There's nothing wrong with the micro switch. It's perfect. So I get my flashlight and I take the bag off of the top of the duct and I look in there and the blower wheel is flat. There's no scoops in all of the squirrel cage blades. Each of the blades was absolutely flat, packed with dust. And it was blowing air, but not enough air. It couldn't make enough pressure to flip the sail switch. So, okay, that was not going to be pretty. Got in there and cleared it out with screwdriver as best and carefully as I could, and put it back on the air, cleaned it up, trying to keep all that crud from getting up in the tube. And a couple days later, we wound up having to take the entire blower cage out because we couldn't get the wheel off of the shaft. And we wrapped the motor up, took it to the car wash, and spray washed it. And man, the crud that came out of that thing, it was filthy. So just you have to approach things from a common sense point of view, not just a technical point of view. Things that don't seem to make sense very often are the things that make sense.
well, let me ask the question this way then, because I believe that it's a wise thing to sweep those lines periodically. Do you see in your practice, do you see things developing in lines that they haven't quite reached that arc over point yet, but you can see it's building?
I do. There are it it everybody has a cousin Murphy. And Murphy says no matter how often you look at something, the day after that it'll break. I usually tell people I'm the wedding photographer. And when I show up, everybody's dressed all pretty and everybody's lovely and the venue is nice. and I take 500 photographs of everything. And when I walk out the door, the food fight starts. This is the same thing in troubleshooting with transmitters and everything else. It doesn't matter how often you do a mechanical inspection on your transmitter, some bolt is going to work its way loose. It doesn't matter how many times you visually inspect anything. If there's a way for something to mechanically go wrong, it will. And very often, right after you did all of that inspection and work and said, okay, everything's hunky-dory, what you hope to find is that you'll see some version of the creeping death working its way into a piece of your gear. For example, I had a Collins transmitter. I went in to do a maintenance on it. I always do full visual inspections. I always wiggle everything. And when I opened the front door to the B plus cabinet, I noticed that the B phase primary lead was looking a little brown. And come to certain, not only was the crimp loose on the bolt a little bit, the crimp was not crimping the wire correctly. And had it gone on for much longer, it would have burned that phase wire right off. So visual inspections are paramount. Physical inspections, tug, wiggle, everything. Make sure screws are tight, connectors are snug, work connectors in and out, just make sure it's got a little something to it. Because you cannot beat a good visual physical inspection. But when you go to line sweep your line, have I had them fail a week or two after I've been there? I have. Did it fail anywhere that had any kind of a point of visual concern in the testing? No. It was just something that came up out of clear blue nowhere. Pilots call that clear blue 22 failure. There I was flying along at 22,000 feet, and then whatever it is happened. Never good. And yes, it does happen. Things just die, or lightning happens, or birds happen, or whatever. But more often than not, if you sweep the line, whatever kind, any kind of line, with any kind of regularity, chances are very good, I'd say in the 70 to 80%, if not better, that you're going to see some kind of creeping death crawling along there. And it's going to be a point where you're going to say, hey, I see this, your return loss is a little different from the last time. I see this little cobra sticking up out of the grass. At this point, I think a sweep in 6 months would be pertinent. And by the way, keep an eye on your VisWire. And I've had some people call me up and go, hey, thanks for the heads up. We're 3 weeks down the line and my VisWire is creeping. Come on back. Or 6 months later, we'll go back and that little snake will still be sitting in the grass, but it won't have changed at all, and neither will the VisWire. So it's just a point of interest, and you keep an eye on it. But you tried, you see something, and you didn't ignore it.
Yeah, very good. Robert mentions here a station that would trip off during high winds with a 7-bay antenna and replaced with a 4-bay. Is that something you've ever seen?
Let me get the facts straight. It was a 7-bay. You changed it out for a 4-bay, and then high winds trip it off. Help me with this.
I didn't go to 4-bay to stop the tripping. I just wanted a different TPO, more raw RF on the aperture.
Okay. And is there a point of failure? Is it giving you grief?
Oh, yeah. When it was windy, I watched the VisWire meter, so we knew that we had to change probably every bullet in the array.
Rigid line?
Yeah, 3-inch rigid, 7 bays. And I watched the 7 bays moving around in the wind. That's when we knew we either had to fix it or replace it.
Face width of the tower?
At that point was about 5 feet across. It was a self-standard.
Height of tower?
No lights.
Oh, I'm sorry, the height.
Oh, the
Okay.
height, I think 247.
And you're near the top?
We were. Yeah, it was channel 11 at the top. 94.7 was the 7 bay.
I'm going to ask you for the make of the antenna.
Oh, Jam Pro.
Not known for problems. Um,
Well, I'm not trying to slam them. I would have gone with anything, but I like the dielectric. That was just a personal choice.
well, they're both excellent antennas, and I had a JamPro down incinerating downtown West Palm Beach for 36 years, and it looked like it'd been through World War IV when we took it down, and it never failed once. So, Alex and I we're good. Um, if you have an antenna that's wiggling in the wind, then it's not mounted correctly, or it was improperly designed and lacks stiff arms, or the method of mounting is not taking advantage of the strength of the tower. Is it face mounted or leg mounted?
Um, Base mounted, and there were two things that you just mentioned that are true in that install. They didn't have arms to keep it rigid, and there were radomes. So it caught a lot of wind.
What wind zone is this?
What wind?
Wind zone? What state?
Mount Wilson, it's only 2,500 feet up, I think.
Only. Okay, so
But it had been up for a long time, so when we changed that out, but that was a situation that went on for years until I got there. I had to do something about it.
well, is there anything on the tower in your aperture? Cables, conduits, other antennas?
Probably the TV's picture and sound lines are going up.
Through your aperture? Past your antenna?
Oh yeah, probably 10 feet above my last bay.
It's not the above part that concerns me. The two things that stand out are, with a 5-foot face antenna, what's your frequency, high or low?
Low.
Not quite so bad. The tower should provide reasonable shielding against changes in the rigid line for the TV station, but any kind of movement back there is going to wander your VISWAR around. And then when you add high wind to it, which is a daily occurrence on Wilson, your proximity to the rest of the tower steel, especially if you're face mounted, you blow it one way, you blow it the other, you're actually doing a tuning null like this, or actually more like this. And your proximity to the adjacent metal, along with the changes in the back plane of the lines feeding another antenna above you, you've got an unstable ground plane. The ground plane that the antenna relies on for a tuning stability constant is not constant. And if you can see the thing visibly walking the dog, even at 250 feet, then your antenna tuning is going to be pretty much all over the road. Now,
Well, it got really bad, and it was the bullets, the black powder.
well,
It took off
what
the very
happens
first
is
90.
when you get flexure like this, none of that stuff is supposed to flex. And what happens is you're taking two planar surfaces that they're parallel like this, and you're causing little gaps. I'm over exaggerating, but you're causing gaps in the bullet. And when you disturb the planar mate of a bullet and an inner, or you disturb the position of that planar condition and it slides, what's your horsepower?
There was 16,000 going up the pipe.
Okay, not super high, but enough for arcing. Whenever you disturb bullets like that, and I mean on a micro scale, you get these arcs, and it arcs and it arcs and it fits and it arcs. And when you get an arc, what's the first byproduct of an arc? I don't care what you arc it through, the answer is carbon. And you get carbon. And then you get an arc and a carbon and a carbon and an arc, and it goes back and forth like a bad game of ping pong with arc and carbon and metal and arc and carbon and metal. And eventually it soots up, and then you start to get worse. And as it gets worse, you get little explosions. And those explosions generate lots more arc, lots more carbon. And then the destruction is no longer linear. The destruction becomes exponential. And then eventually your Viswar starts wandering all over the place. And you'll find an article on the website about tubing cutters. I'm not going to raise this issue here. Everybody's got their own idea about tubing cutters. But you'll see in the article, there is a photograph of a micro comparator. And we actually did some testing of tubing on the comparator. And you could see how at the end of the tubing, the end of it would go down like this. And you would lose your planar contact surface, and all of that energy would be on a ring around the tubing.
That's what I found too.
And
you were barely making contact.
You'll see the bullets burn off when you have a situation like that. But if it's just a matter of wiggle, 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 then you get these exponentially increasing micro explosions. And at that point, you're done. You're looking at all new inners, all new bullets, all new insulators. And if you sooted it up bad enough, you throw the antenna away, because there is no cleaning all of that garbage out of the antenna.
Robert, as long as we've got you here, let's talk about your other item from the chat box, which I think is probably not something that's entirely uncommon.
Hit me.
Gary, it's a low budget AM adding a translator without retuning and filing for an impedance change. Robert says some were running at 10%. Are you saying they folded back that far?
Yes, to keep from burning things up.
Man.
Is this where I'm not supposed to say there's one born every minute?
Well, we talked about this a couple weeks ago, the fact that so many of the mom and pop AMs, let's say, don't have a bridge. They never had a bridge. They never had a spectrum analyzer.
Yeah. Oh, no, they don't have any money either. And I feel for them, I do. And the number of people who are competent to fix that situation the pond is draining fast. And I really don't know what AM people are going to do. FM talent is thin enough. AM talent, gone. At that point, anybody who's any kind of an AM engineer, is this a Omni single tower radiator or an array?
Most of them are non-D, 1 kilowatt.
Oh, thank God.
But there were so many, I just gave up on it.
Well, it sure narrows down the possibility of components. There's going to be, there's no phaser involved, which is nice. And assuming that it's a slightly more modern transmitter, unfortunately, you don't know what the actual transmitter tuning is set to. And most AM transmitters will run anywhere from 40 ohms to 60 ohms without really pitching a fit. Older transmitters will run typically from 30 to 90 ohms without pitching a real fit. So you don't really know what the transmitter is set to, and it would be nice if a dummy load were available, and you could set the output to the transmitter, assuming it's tunable, to 50J0 on a dummy load. And that way the transmitter is set for a reference, and you can watch the transmitter's watt meter and have somebody go out there and play roller derby with a roller inductor or change the taps or what have you, or a variable cap or something, and just take pictures, know where you go, put marks on all of the whatevers, so you can come back to the starting point, please, and play with the tuning on the ATU. And because first of all, you can't make it worse, at least not by a whole lot. And you're subject to the first tier fine, which is $10,000. And if you can make it anywhere near better and run a few more horsepower, then hallelujah, you're on the right path. And if it's just a single stick radiator, you're only going to have 3 or 4 parts in the ATU, if not only 1 or 2. And 1 or more of them is going to be tunable. So, hey, go for broke. You know, that's one of those cases where I believe in the Radio Shack principle. There's no substitute for blind dumb luck, just go for it. But at least if you set the transmitter to a known dummy load and the transmitter is now set and happy to 50J0, then you can tune the ATU to make the transmitter happy. And then you'll know that the ATU plus the indeterminate length of heliax involved between here and there resembles something like 50J0. So you're not totally hosed without a lifeboat. I mean, I've seen people do a lot worse. We had a tower come down, no hope of putting it back up. We ran a long wire from the edge of the building to a tree. I mean, whatever it takes, any port in a storm.
Did I just hear you use the magic words dummy load?
Well, yeah, you want one? I got a pile of them.
Well, once
I got a
again,
nice 2,500.
once again, a
Yes,
lot
I
of
did.
stations don't have dummy loads.
Well, I know. And, you know, a lot of people don't put a dummy load into the budget because they figure they have a brand new transmitter. Who needs a dummy load? Ha, ha, ha. You know, well, you don't need a lot of things until you need them. And then when you need them, you are DOA. Or as the sheriff's department says, GOA, gone on arrival. So what do? Start a club of people who he has a dummy load, he has an analyzer, he has a set of tools, he has a voltmeter, he has a high voltage probe. You all get together for pizza and go fix the damn thing. So just we've done worse. And loser buys. Oh, that's not tough. Somebody give me a tough one. I'll tell a very bad generator explosion story.
Anyone else like to bring up a situation or perhaps relate a troubleshooting joy that they found?
Come on, all this experience, blow me over.
Hmm.
We got 3 centuries of experience here, guys. Come on.
Well, when we were talking about airflow earlier and your blocked blower, one of the things that I noticed back when I was, everything that I was working on, it was a tube type that had a big blower, and the different manufacturers protected the tube in different ways. The one that you were working on, it was pretty common, where you had the little flying switch,
Sail switch.
little wing. But there was another manufacturer that basically had just a pressure switch inside the cavity.
Yeah.
And what we discovered was that if the exhaust coming out of, actually something had fallen off the tower and crushed the exhaust and pinched it completely shut, well, the blower is still turning and it's still producing pressure inside the cavity, but there's no airflow because it can't escape. And that will kill your tube and everything else in it pretty effectively. So you need to know, not only is there pressure in that cavity, but is there motion that allows the hot air to escape.
That's why, depending on who the manufacturer is, 40, 45, 50, and 55 years ago, they went to Dwyer and put in differential pressure switches so that it wasn't just a matter of pressuring the bottom and the top when you seal off that exhaust. It had to actually have negative flow. So that was the whole point between the differential switches, and it eliminated that problem.
I'm going to add to that, Eric, very similar to what you're describing, but some years back, I was asked to watch out over a particular station, and the program director, the receptionist, I can't remember which, but they would tell me every time the station engineer would go out to the site, the station would drop off the air, and they couldn't figure out why. And it became almost a joke that so and so was headed out to the site. So I decided to go out there and watch him one day, and he drove up to the site and walked up to the door, and he went boom, and the transmitter dropped off the air. It was the air switch.
Well, when you run into situations where you're in a building that's using outside makeup air, other than the obvious heat, humidity, filth, and bugs, opening a door like that can be questionable to your airflow. But I'm not a big fan of external air. I mean, we had one down on Stock Island in Key West. Guy had a 35 kilowatt transmitter in a room that was only 51 square feet, and it was 100% outside makeup air in the middle of the salt marsh. And his brand new FM HT35 made it 9 months and lost all the iron. All right, that was interesting. It looks strangely like my website.
Yeah, I thought we should let everyone see this before we're well over an hour now, so that's good.
Can I
And
point out two things on the site of great interest?
sure.
The first one is the tab on the very bottom middle for videos. That's every place where you would never want to see water. And then on the upper row,
Every place where you wouldn't want to see water. Where's that?
oh yeah,
Water piping? No.
water cooling line.
Water cooling line.
Well, there's all of them are water cooled line.
Oh, I see. All right.
Then in the very top row of buttons is the downloads page. Here you'll find articles and PowerPoints and all kinds of things written under the moniker of a series called Don't Do That. Because everybody loves to be told don't do that. But I'll pick a topic that's either important or deliberately controversial and state my case. And the grounding paper here, it's got a little age on it now, but it gets the point across. And I've been doing grounding designs for many, many, many years, and I've protected some multi-million-dollar plants, and I've never had anyone come back and say I goofed. And feel free to take anything you find on the website and enjoy it. There's photos, links, all kinds of fun things.
And coming soon,
Yeah,
coming soon, with
I had
coming
extra
soon.
buttons. You go ahead and click one.
All right. Well, I see.
Flag.
I see a lot of things here that are infrared testing, and of course, the other things that are involved that you take a look at. And if anyone would like to schedule a line sweep or an inspection, I'm sure that you're more than happy to have them give you a call and check in.
Or even a chat.
So,
Oh, a good chat.
all right.
Before write another article.
Before we let Gary get away, anyone else have a question or experience they'd like to share?
Please. Somebody had to have broke something recently.
Well, we
Happy
must have,
people.
we must have a lot of happy people with a lot of smooth running sites.
Fantastic.
So, well, I sure appreciate having you, and I know from what you've been doing and maybe another time you can show us some pictures of some of the line sweeping and the things you see.
I can do that. I have hundreds of pictures of crispy soot-covered stuff.
We'll invite you back when you get your microphone fixed.
I'll work on that. This obviously has a problem.
All right. Eric, did I step on you? Did you have more that I dropped in on you?
No, I think that's all I was going to cover. I mean, the only other thing that I remind the younger folk is to try to have records of what your instruments read when there was nothing wrong. Because I had a rig with a triode in it that would not make any output at all, and the only symptom was a slightly higher filament voltage. And the only reason we had a filament voltmeter, because the transmitter didn't come with one, is that I had added it. And so eventually, after noodling around for a long time, we discovered the open in the, it was an indirectly heated cathode. So there was an open in the heater circuit. The cathode was still connected. Everything was still connected, but it was cold. It was stone cold. And, had I not known that the filament voltage should have been a little bit lower than that, because what had happened is it was open, the power supply had no load on it. So the meter read high. So, if you take on a new client or a new location and everything is fine, that's the day to write down all the meters, the crank handles on the phaser, everything, because one day you'll get some help out there, and having the ideal conditions recorded will help you a lot.
Let me say this about line sweeping too. It's good to have a baseline on your line sweeping, because if you sweep it and it's fine and then something hits the fan, it's good to be able to go back and go, master, we have a copy of the line sweep that you made the last time you were here. And you can look at that and go, what was I thinking when I did this? But it's good to know where you came from, to see where you are, to see, was this a problem before or was it all normal before? So line sweep, good baseline. Baseline's on everything you've got. It's good to be able to say you have a picture of it in action and you touched it once. So do that by all means.
Yep, as was mentioned last week and the week before, when KLAC had that vandalism by the fact that somebody had written down the numbers on the phaser, they got it back real fast instead of weeks.
Happy to help. Always good for a conversation.
When you go out to that site, just be observant. I had an occasion where a new tower was erected fairly close to an AM array, but cell phone company didn't bother to ask anybody or tell anybody, and all of a sudden you can't get the monitor points back in. Well, guess what? You didn't do anything, but somebody else did. So it pays to know what's going on around your site.
There was a case of that in Chicago some years back, where the cell tower was essentially the fifth stick in a 4-tower array.
Yeah, I had an occasion happen, and the funny thing was, and I guess it's not the way it used to be with the cell phone companies had so much money that to prove that they were not responsible for it, they were more than willing to take the tower down and see we were not your problem and put it back up. And of course, when they took the tower down, it's like, hey, look, all the directional patterns are back in again. You guys are going to have to, put that on an insulator and put a network on it to tune it out of the array.
Would have been cheaper to just put a detuning network on it and go away.
Yeah, well, they were sure they were not responsible. And I guess they had crews on hand that could just kill time. It's like, okay, well, you proved my case for me, now fix it.
But as you say, this is really why a maintenance log is so essential, not just that you check your transmitters and such things periodically, but that you write stuff down.
You know, and so many sites don't get visited nearly as often as they should because there's just not enough people and hours in the day. And, you know, any records that you have may prove useful.
Thank you, guys.
Ron Castro says that he called in a lot of engineers to detune new cell towers when he worked for Nokia. And I've seen that too. The power lines, same thing.
Yep.
Put a power line close to a directional array, and you got a lot of detuning to do. Well, again, Gary, thank you. Thank you so much.
My pleasure. Thanks for your time.